So, good morning, welcome to Sakala Vidya educational channel. So, welcome to the engineering mathematics semester 2 classes. So, in this regard we have been discussing differential equations. So far we have discussed part 6 and also problems on variable separable. Still we have some more problems on variables and separable. So, let us complete those problems. After that we shall switch over to the next model. So, now without wasting our time, let us start directly. The previous question, let us see, that is question number 5. Now, today question number 6. Question number 6. Question number 6, note down. Solve the differential equation. Solve the differential equation dy by dx is equal to e to the power of 2x minus 3y plus x square e to the power of minus 3y. Okay, let us solve this question now. Solve the differential equation dy by dx is equal to e power 2x minus 3y plus x square e power minus 3y. So, now how to solve this problem? Let us try to solve this problem now. Right. Okay. See the solution. Given differential equation is is dy by dx is equal to e to the power of 2x minus 3y plus x square into e power minus 3y. See, now e to the power of 2x minus 3y can be written as e power 2x into e power minus 3y. So, that means now this we can write dy by dx is equal to e to the power of 2x into e to the power of minus 3y plus x square into e to the power of minus 3y. See, since we have the formula a to the power of m minus n equals to a to the power of m into a to the power of minus n. So, in the last problems also we have discussed this formula. So, now here e power minus 3y we can take out common. So, e power minus 3y times e power 2x plus x square. Now, it is the product of the two functions. One function is in y, other function is in x. That means this is f of x, this is g of y. So, easily now the functions and variables can be actually separated. So, by separating the variables, so we can have like this. So, we can write dy by e power minus 3y is equal to e power 2x plus x square of dx. So, now this is just like f of y dy is equal to g of x dx, or g of y dy is equal to f of x dx. So, variables separables. So, that means variables have been separated now. So, now what shall we do now? Here we have this can be written as e to the power of 3y dy So, this we can separate e power 2x dx plus x square dx. So, now here, so we used the formula, this is 1 upon a to the power of minus n is equal to a to the power of n. So, using this concept we have written dy by e to the power of minus 3y is equal to e to the power of 3y dy equals to separating here e power 2x into dx plus x square dx. Now, it can be integrated now. So, integrating on both sides, integrating on both sides, integrating on both sides, integrating on both sides. So, integrating on both sides, what do we get? Yes, you are correct. This we can write integral e power 3y dy equals to integral e power 2x dx plus integral x square dx. See, integral e power 3y dy means e power 3y by 3 equals to integral of e power 2x dx is equal to e power 2x by 2 plus integral of x square dx is x to the power of 2 plus 1 3 by 2 plus 1 3 plus constant of integration, right? Am I right like this? Now, actually let us do one thing now here. So, here we applied the formula. In integration we have integral of e power mx dx is equal to e power mx by m plus constant of integration, and also integral x to the power of n dx equals to x to the power of n plus 1 by n plus 1 plus constant of integration, right. So, let us simplify this one now. Let us simplify. How do we simplify? Yes, this can be simplified. LCM of 3, 2, 3 is 6. Multiply both sides with 6. So, multiply both sides with 6, which is the LCM of 3 comma 2 comma 3. So, then we get 6 into e power 3 by 3, that is 2 e power 3y we can write equal to 6 into e power 2x by 2, that is 3 times e power 2x plus 6 into x cube by 3, that is 6x, sorry, that is 2x cube plus 6c. This again 6c we can write c itself only. So, instead of writing 6c, now we can write that as plus constant of integration. So, the terms can be rearranged. Bring 2 e power 3y this side. So, then what do we get now here? So, this 3 e to the power of 2x minus 2 e power 3y plus 2x cube equal to c. So, this is the required general solution of the given differential equation. Okay, let me repeat once again this question now. Let me repeat. So, given differential equation is dy by dx is equal to e power 2x minus 3y plus x square e power minus 3y. Now, dy by dx is equal to e power 2x minus 3y, we can write e power 2x into e power minus 3y plus x square e power minus 3y. E power, take out e power minus 3y common. So, e power minus 3y into e power 2x plus x square. Now, it is in the form of dy by dx is equal to g of y into f of x. Now, we can actually separate the variables. This we can write dy by e power minus 3y is equal to e power 2x x square into dx. Now, so using this one 1 by a power minus n, we can write a power n. This is dy by e power minus 3y, we can write e power 3y dy equal to, now the opening the brackets, e power 2x dx plus x square dx. Integrating on both sides. Integrating on both sides, now what do we get? Integrating on both sides. So, integral of e power 3y dy equals to integral of e power 2x dx plus integral of x square dx. Since we have integral e power mx dx is equal to e power mx by m plus constant of integration, integral of x to the power of n dx is x to the power of n plus 1 by n plus 1 plus c. So, now integral of e power 3y dy is e power 3y by 3 equals to integral of e power 2x dx is e power 2x by 2 plus integral of x square is x to the power of 2 plus 1 by 2 plus 1 x cube by 3 plus constant of integration. LCM of 3 comma 2 comma 3 is 6. So, multiply both sides with 6. So, with 6. Then what do we get now? 6 into e power 3y by 3, that is 2 times e power 3y. Otherwise 6 by 3 is 2 e power 3y. Here 6 by 2, 3 e power 2x, 6 by 3, 2x cube. This is 6c, 6c nothing but constant, we can write c only. So, now take 2 e power 3y this side, 3 e power 2x minus 2 e power 3y plus 2x cube is equal to actually negative c also. Here it is a constant, we can write positive c itself only. This is constant of this integration we need to write. So, this is the required general solution of the given differential equation. So, sixth problem we have completed. So, now let us move to next question. Question number 7. Question number 7. So, all of you look at the screen and note down the question. Find the solution of dy by dx is equal to minus x upon y at x is equal to 1 and y is equal to root 3. So, that means in this case we need to find out the particular solution. First we need to solve the equation, we will get the differential equation, that is general solution. After getting the general solution, if you substitute x is equal to 1 and y is equal to root 3, you will get the particular solution. Okay, now this is in the form of dy by dx is equal to f of x by g of y form. So, now cross multiplication directly we can write in the variable separable form. Let us solve this question directly. Given differential equation is dy by dx equals to minus x upon y. So, simply on cross multiplication what do we get? Y dy is equal to, you get minus x dx. So, variables and also got separated now, directly integrating on both sides. So, integrating on both sides. So, integrating on both sides. So, now what do we get? That is integral of y dy, negative common, integral of x dx. So, integral of y dy is y square upon 2 or by 2 equal to minus integral of x dx is x square by 2 plus constant of integration. See, here we have the concept. What is the concept? Means integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus constant of integration. So, integral of x dx means here n is equal to 1. So, x to the power of 1 plus 1 is 2 and 2, x square by 2 plus constant of integration. Similarly, integral of y dy is also y square by 2. So, multiply both sides with 2. Then what do we get now here? 2 by 2, 1 into y square is equal to negative x square plus constant of integration 2c, but write down c, no problem. Bring minus x square that side, you get x square plus y square is equal to c. But this is the general solution, but we need to find out the particular solution at a given particular values. X is equal to 1 and y is equal to 3. So, substituting x is equal to 1 and y is equal to root 3 in equation 1, we get the particular solution. This is very important problem. See, let us, so now write down substituting x is equal to 1 and y is equal to root 3 in equation in above equation, in equation 1. So, we get as follows: x square means 1 square plus y square means root 3 square, so equal to c. That implies c equals to 1 plus root 3 square 3, 4. Again substitute c is equal to 4 in equation 1. Therefore, we get x square plus y square is equal to 4. What does it represent? It represents equation of the circle whose center is at origin having radius 2 units. So, it represents one of the actually equation of the family of circles. So, this is the required solution. Required, not general solution, particular solution. So, say required solution. I hope you might have understood this one. If you have any doubt, you can chat with me. I already told you it is meant for only subscribers only mode. Those who subscribe our channel, they are able to chat, live chat with me. So, you can interact with during live session. Right. Right. See, the given differential equation is dy by dx is equal to minus x by y. By cross multiplication, we get y dy is equal to minus x dx. Integrating on both sides, integral of y dy is equal to minus integral of x dx. See, integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. So, integral of y dy is y square by 2 equal to minus integral of x dx is x square by 2 plus constant of integration. Multiply both sides with 2. So, we get 2 into y square by 2, y square is equal to 2 into minus x square by 2 minus x square plus 2c only you will be getting here 2c. 2c means say just c, constant, mere constant. So, now instead of 2c, c we have written. Now, bring minus x square this side, x square plus y square is equal to constant, say equation 1, this is the general solution, but substituting x is equal to 1 and y is equal to 3 in equation 1, we get 1 square plus root 3 square is equal to c. So, c equals to 1 plus root 3 square is 3, 4. Again substituting c value in equation 1, we get the particular solution, that is x square plus y square is equal to 4, which represents equation of the circle whose center is at origin having radius 2 units, or it represents one of the family members of the system of family of circles itself only. This is the required solution. Okay, let us move to next 8th question now. Question number 8. Solve the differential equation. Solve the differential equation. Solve the differential equation. Solve the differential equation. E power y plus 1 cos x dx plus e power y sin x dy equal to 0. So, this is the differential equation. Right. Given differential equation, write down first. Given differential equation is given differential equation is e power y plus 1 of cos x dx plus e power y sin x dy equals to 0. Now, we need to put in the form of f of x dx plus g of y is equal to dy. So, that means it should contain only function of x, it should contain only function of y. So, that means here the function of y here e power y plus 1, here function of x sin x. So, multiply these two, we get sin x into e power y plus 1. If you divide both sides by sin x into e power y plus 1, then it can be put in the form of f of x dx plus g of y dy is equal to 0. So, now dividing both sides or divide both sides by sin x of e power y plus 1. So, now we get right, what do we get? E power y plus 1 cos x dx divided by sin x into e power y plus 1 plus e power y sin x dy divided by sin x into e power y plus 1 equals to 0 by something 0. Then what happens now here? E power y plus 1 gets cancelled, e power y plus 1 1 ja, here sin x 1 ja will be cancelled. So, now we have, it's very interesting, cos x by sin x, do not write cot x, keep as it is, cos x by sin x dx plus this we can write e power y upon e power y plus 1 dy is equal to 0. Now, which is in the form of f of x dx plus g of y dy is equal to 0. So, this is variable separable form, one of the variable separable form. So, that we can directly integrate it in order to get the general solution now. So, integrating on both sides, integrating on both sides, integrating on both sides, integrating on both sides, what do we get now? Integral of cos x by sin x dx plus integral of e power y by e power y plus 1 dy equals to 0. Sorry, instead of this, better you can write constant of integration. See, it's very interesting. If you observe here, integral cos x by sin x dx, cos x is the derivative of sin x, d by dx of sin x is cos x. So, that means f dash x by f of x dx form. Here e power y plus 1 differentiation is e power y. So, now this we can write log mod sin x, this we can write log mod e power y plus 1 is equal to, constant can be written any one of the form, as all the terms are logarithms, write down log c, it makes no difference. So, here very important formula in integration you should remember, integral f dash x by f of x dx is equal to log mod f of x plus constant of integration. So, both the terms are in this form itself only. So, directly I have written log mod sin x plus log mod e power y plus 1 log c. And one more interesting, from logarithms, the properties of the logarithms. So, this can be written as log of mod sin x times e power y plus 1 is equal to log c. So, here what is the property we have? The property is, since log a plus log b is equal to log of ab, log of product of the numbers, log of ab. So, now comparing on both sides, what do we get now here? Comparing on both sides, therefore, we get sin x times e power y plus 1 is equal to c. So, this is the required general solution, right. Okay. Once again, this is our solution now. This is our solution. You can go through it once again. If you want, you can take the screenshot also. Let me repeat the question. See, the given differential equation is e power y plus 1 cos x dx plus e power y sin x dy is equal to 0. So, dx should contain all the terms of x only, function of x itself only. So, but here we have e power y plus 1, dy should consisting of only function of y. So, that means it should not contain sin x, and it should first term should not contain e power y plus 1. Multiply these two terms, sin x into e power y plus 1. So, divide both sides by sin x into e power y plus 1, we get, so e power y plus 1 cos x dx by sin x e power y plus 1. E power y plus 1, e power y plus 1 cancel, we get cos x by sin x dx plus next e power sin x by sin x e power y plus 1, e power y sin x dy by sin x e power y plus 1. Sin x gets cancelled, we have e power y by e power y plus 1 dy, which is equal to 0. So, now which is in the form of f of x dx plus g of y dy is equal to 0. Now, integrating on both sides, integral of cos x by sin x dx plus integral of e power y by e power y plus 1 is equal to c. Cos x is the derivative of sin x. So, f dash x by f of x dx log f of x, using this formula, log mod sin x plus similarly e power y plus 1 derivative is e power y 1. So, log mod e power y plus 1, c can be written in the form of log c. So, this log a plus log b is equal to log of ab. So, log of mod sin x into e power y plus 1 is equal to log c. Comparing this, sin x e power y plus 1 is equal to c. So, sin x into e power y plus 1 is equal to c. This is the required differential equation. This is the required differential equation. Okay. So, now it is very important. We have completed actually here variable separable method, but in that we have special case is there. Now, we are going to discuss special case, equations reducible to variable separable form. So, the given equations are not directly cannot be put in variable separable form. Using some mathematical manipulation, it can be reduced into the variable separable form, so that we can find out the general solution. So, let us have a discussion on that one. See, sometimes a given equation dy by dx is equal to f of x comma y, first order first degree differential equation, will not be of variables separable form, variables separable form, but it is of the form dy by dx equals to ax plus by plus c whole to the power of n, where a comma b comma c are constants. So, it can be reduced to variables separable form by substituting ax plus by plus c equals to v or z or t, anything. Some textbooks may use v, some textbooks may use z, some textbooks may use t also. So, let us solve some problems for better understanding of this concept. Equations reducible to the variable separable form. Okay, now dy by dx is equal to f of x comma y will not be in variable separable form, but it is in the form of dy by dx is equal to ax plus by whole to the power of n form, or something sin of x plus y log of x plus y form also it may be. So, then in the place of ax plus by plus c is equal to, we need to select the variable either v or z or t. So, easily that can be put in variable separable form, so that we can find out its general solution. So, let us proceed for this one now. Let us move to the directly. Now, the question number 9, already we had a discussion that one. Question number 9 is based on equations reducible to the variable separable form. Solve dy by dx is equal to 4x plus y plus 1 whole square, right. So, this is in the form of dy by dx is equal to ax plus by whole to the power of n form. So, now the solution let us write. Given differential equation is given differential equation is dy by dx is equal to 4x plus y plus 1 whole square. Say this is equation 1. Let us substitute. Put 4x plus y plus 1 is equal to t. Differentiate both sides with respect to x. Differentiate both sides with respect to x, right. Then what do we get? Let us see. Differentiating both sides with respect to x, x differentiation is 1, 4 plus y differentiation is dy by dx plus 1 differentiation is 0 dt by dx. So, that means now the dy by dx can be written in terms of dt by dx. So, dy by dx is equal to, we can write dt by dx minus 4. Say this is equation 2. Substituting dy by dx, substituting 4x plus y plus 1 is equal to t in equation 1, and substituting dy by dx is equal to dt by dx minus 4 in equation 1. So, that means from equations 1, better you say this also 2, say 3, 1, 2 and 3, we get what do we get now? In the place of dy by dx, we can write dt by dx minus 4 equals to, in the place of 4x plus y plus 1, t has been replaced. If you put t, you get t square. So, this can be written as dt by dx equals to t square plus 4, that is all, t square plus 4. Now, easily we can actually separate the variables now. Here dt by t square plus 4 is equal to dx, you can write it, dx you can write it. So, that means now separating the variables, we have this, we can write dt by t square plus 4 equal to dx. Can I write like this? dt by dx is equal to t square plus 4 itself only. So, now integrating on both sides. Integrating on both sides. So, integrating on both sides, what do we get? Integral of 1 upon t square plus 4, we can write 2 square dt equal to integral of dx. Do you have any idea what is the integral of 1 by t square plus 2 square dt? Yes, this is nothing but 1 upon 2 tan inverse t upon 2 is equal to integral of dx is x plus c. So, my dear students, please remember this concept, this is very important. Integral of 1 upon a square plus x square dx, a square plus x square dx is equal to 1 upon a tan inverse x by a plus constant of integration. So, this is very important concept to be remembered. in order to solve this problem. This is very important concept. I hope it's very clear to you now. Clear? So now what shall we know? Here t is the dummy variable. Now t we need to again replace from equation 2. T means 4x plus y plus 1. So therefore we get now, therefore half into tan inverse 4x plus y plus 1 upon 2 or divided by 2 equals to x plus constant of integration. This is the required general solution. General solution. I hope it's very clear to you. Okay, now let us move to the right. Let us move to the once again this same question itself only. The ninth one. Solve dy by dx is equal to 4x plus y plus 1 whole square. This is not directly in the form of actually dy by dx is equal to f of x comma y. So given differential equation is dy by dx equals to 4x plus y plus 1 whole square. Say equation 1. Put 4x plus y plus 1 is equal to t or v, some textbooks z also you can write, no problem. Differentiate both sides with respect to x. 4x differentiation 4 plus y differentiation dy by dx 1 0, t differentiation with respect to dt by dx. So now here we should write dy by dx in terms of dt by dx. So dy by dx is equal dt by dx minus 4, say equation 3. From equations 1, 2, 3 we get, so instead of dy by dx we can write this one dt by dx minus 4 equal to, instead of 4x plus y plus 1 t, so it becomes t square. Now dt by dx is equal t square plus 4. Separating the variables, now what do we get? Dt by t square plus 4 is equal to dx. So after separating the variables, integrate on both sides. So integrating on both sides, what do you get? Integral of 1 upon the 4 can be written 2 square, 1 by t square 2 square dt equal to integral dx. Now this is 1 upon 2 tan inverse t by 2 equal to integral of dx is x plus c. So we have the concept integral 1 upon a square plus x square dx is 1 upon a tan inverse x by a plus c. So now again, now what shall we do now? In the place of this t, write down 4x plus y plus 1 by 2 of tan inverse of 4x plus y plus 1 by 2 equals to x plus c. This is the required general solution. So this is our question now. Now let us move to the 10th question now. 10th question. Question number 10. Note down question number 10. Solve dy by dx equals to secant of x plus y. Secant of x plus y. Secant of x plus y. Though it is in the form of dy by dx is equal to f of x comma y, so variables directly cannot be separated. So then what shall we do now? Substituting or selecting, choose x plus y is equal to either v or z or t. Let us take t itself only. Now it can be put in, it can be reducible into the variable separable form so that it can be integrated and so as to find its general solution. Right. Given differential equation is given differential equation is dy by dx equals to secant of x plus y. Say equation 1, this is clear. Now put x plus y is equal to t. Say equation 2. Differentiate both sides with respect to x. So x differentiation 1 plus y differentiation with respect to x is dy by dx, derivative of t with respect to x dt by dx. Now let us write dy by dx in terms of dt by dx. So you are going to express dy by dx in terms of dt by dx. Dy by dx equals to dt by dx minus 1. Say equation 2, right. So now from equations 1, 2 and 3. So what do we get? In the place of x plus y, replace t. In the place of dy by dx, dt by dx minus 1. So now we get dt by dx minus 1 equals to secant t. Now dt by dx is equal to 1 plus secant t. So now this 1 plus secant t we can write 1 plus secant t means 1 by cos t. Here LCM cos t. So then we can write cos t plus 1. So now interchanging here, what do we get? dt by dx is equal to cos t plus 1 by cos t. Then what do we get now? Here we get this can be rewritten as dt into actually cos t by 1 plus cos t we can write. This is we are going to write cos t upon 1 plus cos t dt is equal to dx. Now integrating on both sides. So integrating on both sides, then what do we get now? Let us see. Integrating on both sides. So integrating on both sides we get like this now. This is integral of cos t upon 1 plus cos t dt equal to integral of dx. So this cos t we can write for our convenience integral. In the numerator add 1, subtract 1. 1 plus cos t minus 1 upon 1 plus cos t dt write down. Clear? Integral of dx is x plus constant of integration. Further it has to be continued, right. So now what shall we write now? This one, this 1 plus cos t by 1 plus cos t 1, that is integral dt you can write, minus integral of 1 upon 1 plus cos t dt equals to x plus c. See, since we have 1 plus cos x equals to 2 cos square x by 2. This is the formula, this concept we need to use. This is the formula for multiple and submultiple angles. 1 plus cos x is equal to 2 cos square x by 2. So we can write integral of dt is t minus integral of, so 1 upon 2 cos square x by 2 dt, sorry, t by 2 dt. Let us write clearly. Okay, this is integral 1 plus cos t. So t minus this is integral 1 by 2 cos square t by 2 dt, right, equal to x plus c. Now what shall we do now? This is see very interesting now, very interesting. So 1 by cos is secant, so this we can write t minus 1 by 2 common, integral of secant square t by 2 dt is equal to x plus c. See my dear students, integral of secant square x dx or secant square mx dx, that is equal to tan mx upon derivative of mx is m plus constant of integration. Similarly, here integral of secant square t by 2 is tan t by 2 upon 1 by 2. 1 by 2 means 2 you will be getting here. This is equal to t minus 1 by 2 into, this is 2 times tan t by 2 you will be getting, equal to x plus c. And 2 will get cancelled. We have t minus tan t by 2 equal to x plus c. Now substitute t value. What is t? T is nothing but x plus y. T is nothing but x plus y. So now substituting t for actually here x plus y, we get the general solution. We get the general solution. So our general solution is C. Therefore x plus y minus tan of x plus y by 2 equals to x plus c. Here x gets cancelled, so that implies y minus tan of x plus y by 2 equals to constant of integration. This is the required general solution. This is the answer. Or you can write y minus c is equal to tan of x plus y by 2, or y plus c is equal to tan of x plus c by 2. Anything, this is also correct answer. Or y is equal to c plus tan of x plus y by 2. Any way you can write it, no problem. So this is our answer, right? See once again, problem seems to be very simple, but actually here mathematical manipulations are more, but very easy problem, no doubt at all. See, let me revise once again this question, don't worry. See, the given differential equation is dy by dx is equal to secant of x plus y, say equation 1. Put x plus y is equal to t, this equation 2, differentiate both sides with respect to x. So 1 plus dy by dx is equal to dt by dx. Now dy by dx is equal to dt by dx minus 1, say equation this is 3. From equations 1, 2 and 3 we get, in the place of dy by dx, dt by dx minus 1, and in the place of x plus y t, so secant t, dt by dx is equal to 1 plus secant t. We don't have direct integration for 1 plus secant t, that's why actually if you write 1 upon 1 plus secant t, it's very difficult. So let us convert into the cos term. So 1 plus 1 upon cos t, this cos t is the LCM, cos t plus 1 by cos t. So now if you cross multiply, we get like this, cos t by 1 plus cos t dt is equal to dx, integrating on both sides. So, integrating on both sides, integral of cos t by 1 plus cos t dt is equal to integral of dx. So, this cos t we can write add 1 subtract 1, 1 plus cos t minus 1 by 1 plus cos t dt, 1 plus cos t by 1 plus cos t 1 into dt dt minus integral of 1 by 1 plus cos t dt, integral of dx is x plus a constant of integration, right. I hope. So, now here see what do we get now here. Here we have the formula 1 plus cos x is equal to 2 cos square x by 2. So, 1 plus cos t is equal to 2 cos square t by 2. So, integral 1 by 2 cos square t by 2 dt is equal to x plus c. 1 by 2 common, 1 by cos square is secant square t by 2 dt. So, x plus c. Integral of secant square mx is tan mx by m plus c. So, integral of secant square t by 2 is tan t by 2 by 1 by 2, that is 2 tan t by 2, already 1 by 2 is there, 2 gets cancelled. We have t minus tan t by 2 is equal to x plus c by 2. Replace t is equal to x plus y, then what do we get? So, now we get here x plus y minus tan of x plus y by 2 is equal to x plus c, x will get cancelled. So, we have y minus tan of x plus y by 2 is equal to c. This is the required solution. So, this is question number, we have completed 10th question. Now, let us move to the 11th question. Question number 11. Solve dy by dx, solve dy by dx equals to cos of x plus y plus sin of x plus y, sin of x plus y, cos of x plus y and sin of x plus y. Okay, note down this question and try to solve yourself. I will give 2 minutes time to you. Okay. Given differential equation is given differential equation is dy by dx is equal to cos of x plus y plus sin of x plus y. Say equation 1 this is. Put t is equal to, put x plus y is equal to t. Say equation 2 this is. Differentiate both sides, with respect to x, derivative of x is 1 plus derivative of y with respect to x is dy by dx, derivative of t with respect to x dt by dx. Now, let us write dy by dx in terms of dt by dx. So, dy by dx equals to dt by dx minus 1, say equation 3. So now from equations 1, 2 and 3 we get so in the place of dy by dx we can write dt by dx minus 1 in the place of x plus yt so cos t plus sin t. Okay, transpose -1 to the right hand side, so then we get dt by dx equals to 1 plus cos t plus sin t. I hope it's very clear to you, right? Okay, once again actually all of you subscribe to this channel. Okay, right. So now this is equal to, we get now 1 plus cos t is equal to 2 cos square t by 2 and plus sin t you can write 2 sin t by 2 cos t by 2. 2 sin t by 2 cos t by 2. So we can take out here 2 cos square t by 2 common. If you take 2 cos square t by 2 common, what do we get now here actually? You will be getting 1 plus sin t by 2 by you will be getting cos t by 2. Cos t by 2. Actually this is cos square t by 2 by cos square t by 2 right on. 2 cos square t by 2 taken common out. So this we can write 2 cos square t by 2 1 plus tan t by 2 cos t by 2 is, sorry, sin t by 2 by cos t by 2 is tan t by 2. Very interesting, beautiful problem this is. See, I will write the formula concept here. This concept better you remember. So what is the concept means? First concept, see, 1 plus cos x is equal to 2 cos square x by 2, and whereas sin x equals to 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2, right? 2 sin x by 2 cos x by 2. So now let us transpose this. We can write dt by 2 cos square t by 2 and 1 plus tan t by 2, right? Now we are going to separate the variables. Then what do we get now here? So dt by 2 cos square t by 2 to 1 plus tan t by 2. 1 plus tan t by 2 equals to dx, you will get it. So here 1 by cos square t by 2 is secant square t by 2. This we can write, so 1 by 2 times secant square t by 2 by 1 plus tan t by 2 dt equals to dx. Now integrating on both sides. So now integrating on both sides. Integrating on both sides. So this we can write integral of, for our convenience, of secant square t by 2 divided by 1 plus tan t by 2 dt equal to integral of dx. See, my dear students, very interesting step we are going to get here. that is 1 plus tan t by 2 derivative is secant square t by 2 into half. So, this is f dash x by f of x. So, we can write this is log mod 1 plus tan t by 2 equal to x plus c. Because I will write once again here, since integral f dash x by f of x dx, this is one of the beautiful general formulae from integration log mod f of x plus c. See, the 1 plus tan t by 2 derivative is this one. So, we get log of 1 plus tan t by 2 x plus c. Clear? Right. So, now again substitute t stands for x plus y. So, therefore, we get now, so therefore, log mod 1 plus tan of x plus y by 2 equal to x plus c. This is the required general solution. So, I will explain once again in the next session also this question. Once again go through this question clearly. So, this is the question, right? You can check the question. Right. Okay, once again go through this question. I will repeat this question also, same question, and day after tomorrow we are going to start with exact differential equations. That is actually first degree differential equation itself only. We are going to discuss exact differential equations in the next session. Thank you, bye bye.